hope I'm to understand there. Everybody hears me? Yeah. So it's an honor for me to have this intro for that session and to be invited by Brian. And so I want to do this intro. So I'm the CEO of Oceanloop. Oceanloop is a company based in Germany. We operate 2 farms for land-based farming of shrimp, running shrimp. We are one of the European pioneers doing that, but we have also heritage in fish, and I will show you some of our projects we've done also during my talk. So I think everybody in the room knows what RAS is, recirculating aquaculture systems. I think they gain importance. They can be disruptive. They will change the industry. When we started 25 years ago, we were doing this mainly for protecting the environment. That was the main issue. We had a cooperation with universities in Germany. But nowadays, I think it's changed. So we have not to protect the environment, we have to be protected from the environment. And this is something what was recently published by the World Economic Forum. So 1,500 experts were asked where they see risk in the future. And you see that the top 4 ranked ones are environment risks. And you see this also already in strategies of insurance policies, that it's not so easy to get insurances based on open water systems. It's more easy for recirculating systems. So I think around the world we have different kinds of land-based farming. So we have different, also we have RAS, we have the hybrid systems, we have flow-through farms. All the are defined as kind of land-based systems. So it's a bit mess in the definition, I guess. But you see that we have various species, like salmon, trout, kingfish, a lot of prominent examples. And I think that land-based farming will definitely disrupt the seafood industry. I think there are a lot of studies out there indicating that. I think 10 years ago it was, I think it's still kind of a competition maybe of open shore, or not near shore aquaculture, like cage farms, which are more offshore, and the land-based. But I think land-based projects, they gain a little bit more interest from the investor side. As intro, I like that image a lot. This is showing one of the first pilot systems we are operating for European sea bass. You see that we have quite a high stocking density. It's an indoor environment, interaction with the human. We have clear water. It looks like ocean-like, and I think this is something what we have to achieve with RAS technology. And another example is that one for the Leopoldstrasse sea bream in one of our big farms. I like this also because this is a project of art students, and as we do animal mass cultivation, we were a little bit having the problem in Germany how we can get a better understanding from consumer side. And the art students, they had the idea to make these kind of underwater videos, and they were going to the consumers in the shopping mall and were asking, what do you see? And the consumers, they were just answering a fish swarm in the sea. And then they said, no, it's not in the sea, it's in a RAS, you know. And this is, I think, can be a little bit game changer also for mindset. You see a rendering of one of these projects, and you will see also in this video a little bit how it works, that farm. What is the advantages of RAS? I think, and we have seen this in a lot of hatchery projects where we started to better or to optimize the environment in the farm, like temperature, for instance. That was one of the main reasons why we started in the past to close the water cycle. And we always say, when you do a RAS, you can optimize on every parameter, so it's more the challenge to know what is the best fit for the certain species you have. And then you can control and optimize your system. You have it all year round in the same way. You can optimize the production. Of course, we have technological challenges, and I will come to this later. But you have this advantage, and this is a competitive advantage, but you have also to use it to balance out the additional cost recovery. Another aspect which I think is really important in the future is not just closing the water cycle and optimizing water parameters, it's also that we have access to the waste streams in a much better way than open water. So when we close the water cycle, we can have really extremely concentrated waste streams, and this makes it more valuable to work with these kind of resources. Another aspect is that, and you see this pretty well in this farm, so we have in this farm 4 different RAS, and all the RAS are operated by different species. So what is also possible, you can create like a seafood portfolio, and this will improve your market acceptance. So it makes a big difference if you are just a shrimp farmer or a fish farmer for your pet sea bream, or you have a portfolio of different species. And this is locally farmed, fresh, more sustainable, and you can address these characteristics to your B2B and B2C clients. And I think there's a lot of potential also in that. And everybody knows in the room we have a huge diversity in aquaculture species already today. So with that kind of platform technology, you can at the end farm certain different species. They can be exotic. So like we did, for instance, in Europe, we do the running shrimp in Europe. We started a project where we have the giant grouper from Queensland, Australia now as the first mover in Europe. So this is gaining a lot of attention, and with this niche farming, you can have much higher price points as well. And you see this portfolio here, and certain pressures in the product, and at the end, also you achieve higher prices. So we have our production tank, and we have the water treatment system, and of course it's the question how much and what kind of technology we need. I think that's why we are here today. So how much and what technology is required? So definitely the species can have an impact on that. So there are different biological limits for different species, density requirements, and so on. So it has to be considered what kind of species you have. We have more the philosophy to make it ocean-like, and that allows us to act as a platform technology so that we can even produce in the same system shrimp, but also grouper, for instance. So you have average stocking densities of 5 to 10 kilograms per cubic meter, and the grouper can go up to 150. It's a big difference. Water renewing, water source, of course, it's an element. You don't have access to natural seawater, you have to use artificial seawater, and then you have water renewal rates, let's say below 1% a day. And this means also artificial seawater is quite expensive, so you have to save on that, and then you have to recycle much more water. And of course, identification is also there. I think in the next talk we will hear a lot about budgeting, but I think this is really, really important. That's why one slide to that. We have the kind of a nutrient budget of our fish. We have to feed the fish. We need the diet, and we need also the oxygen. And then we have several excreta, like ammonia, for instance, and CO2, and also particulate ones like the PCS and also the soft organic. So for every sink we have, and for every thing we need for the fish, we have kind of a system, and I just named the various talks after me into that slide, addressing all the different needs we have in the recirculating aquaculture system. We need a feeding system, oxygenation system, the biofiltration, the degassing. Yeah, we have an ozonation for disinfection, but also to work with the soft organic components. We have the solid renewal process. And then we have also, of course, the climate control, the tank design, piping design, which are really important elements. There's one element missing, and this is the water circulation in itself. It's the pumps. Water circulation, and I will put a lot of attention to that in my next slides. This is really, really important, and that's why I try to address that. But before doing so, I want to point out maybe that slide here. There was just a recent publication by Professor Waller from Germany as well, which is one of the pioneers in these RAS systems in Europe. And he did just a schematic scheme of an overview about the elements in the modern RAS. But what's more important, I think, are these connections between these elements. And I think there are 3 main challenges in the RAS industry today. It's definitely off-flavour control. You know that a lot of projects we have to purge, but it's not needed to do it right. We have the H2S problems, and I think